Imagine trying to change a fully grown adult's core moral values
Wow.
by sending them to a mandatory weekend HR seminar.
Right. Yeah. Good luck with that.
Exactly. I mean, they might comply while they're sitting in the office, but their deep-seated beliefs haven't actually changed in the slightest.
Oh, for sure. They're just playing along.
Yeah. And for the machine learning engineers, researchers, and lab leads tuning in to AI paper slog today, that is exactly what we are doing to our frontier models right now with post-training alignment.
It really is.
We're jumping right into a paper titled Synthetic Persona Pretraining, Alignment from Token Zero, which is by researchers from EPFL, the University of Toronto Northeastern, and a few others.
It's a fantastic piece of work.
So here is your 60-second core insight for this deep dive. Right now, standard alignment techniques like SFT and RLHF, they're fundamentally post-training afterthoughts.
Yeah, just tacked on at the end.
Right. They act as this thin behavioral overlay applied after models have already established their priors from trillions of pre-training tokens.
Which is a massive problem.
It is, because since it's merely an overlay, models are fragile. They're highly susceptible to jailbreaks. So this paper proposes a structural paradigm shift called Synthetic Persona Pretraining, or SPP.
SPP, yeah.
And the objective is to install a desired, constitutionally aligned assistant persona from the very first token of pre-training.
Token zero.
From token zero, exactly. They achieve this by appending synthetic first-person moral reflections to roughly 10% of the pre-training documents.
And then they explicitly bind it later.
Yeah, they explicitly bind this persona during the post-training phase. And the result, significantly deeper value alignment, markedly better out-of-distribution moral reasoning, and higher jailbreak robustness.
And the best part, all of this is achieved without paying any capability tax on general benchmark.
Not at all.
And that last point about the capability tax, that is just critical. For the ML practitioners listening, this challenges the long-standing accepted pipeline of pre-train on absolutely everything to maximize the world model, and then just try to align it later.
Yeah, the classic build first, fix later approach.
Exactly. We are essentially looking at a fundamental rewrite of how we engineer an AI's internal representation of values.
Okay, let's unpack this. Because to understand what SPP does mathematically, we really need to look at why that standard alignment paradigm is failing us so consistently.
Right.
I mean, we've all seen it. A lab spends weeks running RLHF. The model's reward curves look great. It seems perfectly safe.
And then it just breaks.
Literally 5 minutes after release. Someone on the internet bypasses the entire safety filter with a simple role-play prompt. Why is that post-training layer so incredibly brittle at the representation level?
Well, it really comes down to something the researchers identify as the persona selection model hypothesis.
Okay, what does that mean?
So during the pre-training phase, when a massive model is just churning through the DOLMA or refined web datasets, it isn't just learning language syntax and objective facts.
Right, it's learning everything.
Yeah, it's learning to simulate a massive, high-dimensional repertoire of diverse personas found in that corpus.
Like who?
It maps the probabilistic text distribution of a Reddit troll, right? Or a toxic 4chan user, a corporate PR representative, a Wikipedia editor, you name it.
It's just internalizing all of them.
Exactly. So when you finally get to post-training with SFT and RLHF, you aren't actually building a brand new, inherently safe persona from scratch.
Because the weights are already settled.
Right. The model's weights are mostly frozen in their macro structure. You are really just wiring together a patchwork of these pre-existing behavioral fragments and updating, superficial routing circuits.
So to bring back the HR seminar analogy, the underlying unaligned personas are still fully intact within the model's weights. They're just dormant.
Precisely. They're just asleep. And the scary part of that analogy is what it means for the network's geometry.
How so?
Well, subsequent fine-tuning, or a cleverly worded adaptive jailbreak, can easily bypass that thin HR seminar training.
Because the toxic distributions are still mapped out in the latent space.
Exactly. The jailbreak just provides the right context window to shift the model's attention heads away from the safety circuits.
And right back toward those highly developed toxic subnetworks.
Yeah, the ones that were completely solidified during pre-training.
Wow. Okay, so if the traditional method leaves these toxic pathways intact, how do we practically engineer a structural soul into a massive pre-training data set from the ground up?
It's a huge logistical challenge, yeah.
I mean, we're talking about data sets like the DOLMA 3 mix, trillions of tokens. How do you inject a consistent constitutional persona into that kind of scale without just completely breaking the compute budget.
So the mechanics of SPP here are actually incredibly elegant. You don't rewrite the whole data set.
Oh, you don't?
No, the researchers just took a subset of the pre-training documents, about 10% of the total pre-training budget.
Which is how much data?
That ended up being roughly 51.4 million documents.
Okay, still a lot, but manageable.
Right. So first, they used a classifier model called SafeLM to scan this text.
Like a harm filter.
Exactly. Any document scoring a 3 or higher on their 0 to 5 harm scale was targeted for intervention.
Makes sense.
But, and this is a really crucial step for maintaining the model's general utility, they also targeted an equal amount of completely benign, harmless documents.
Wait, really? But if you're targeting 50 million documents, running a frontier model for inference to generate responses on all that text, I mean, that is a massive compute overhead. How did they optimize the generation pipeline?
Cost is always the bottleneck at pre-training skills, for sure. They needed a generator model to write a first-person reflection that contextualizes each document based on a normative constitution.
Right.
So they rigorously evaluated different generators. They looked at massive models like Nemotron 3 Super 120B and GLM 4.5 Air.
The heavy hitters.
Yeah, but they actually selected a much smaller model, Quen 3.535B A3B.
Wait, a 35 billion parameter model outperformed a 120 billion parameter model on generating constitutional reflections.
It did, yeah. Largely due to how Quen 3.5 is instruction-tuned and aligned for specific reasoning tasks.
That's wild.
On their automated judge score metric, Quen 3.5 scored a 4.498 out of 5, which is actually the highest quality among all the candidates.
Wow. And the cost?
Way cheaper. It only cost 26.6 thousand GPU hours for the entire 102 million document workload.
Compared to what for the bigger one?
The 120B Nemotron model cost over 28,000 hours and, like I said, actually scored lower on reflection quality.
Oh, wow.
So they optimized for both computational efficiency and alignment depth at the same time.
I have to push back on the architecture side of this, though.
Sure, go ahead.
If we inject 50 million moralizing reflections into the pre-training data, aren't we going to severely bloat the context window?
It's a valid concern.
I mean, and disrupt the cross-entropy loss curve? Standard next token prediction penalizes the model if it gets the text wrong. I'd worry we're going to turn the model into this, like, over-refusing nag that moralizes every time you just ask it to write a standard Python script.
Right. This raises an important question, and it's exactly why their methodology relies on a specific loss masking strategy.
Loss masking.
Yeah, rather than just appending raw text blindly. When they append the synthetic reflection to the end of a document, it's preceded by a special assistant token.
Okay, I'm following.
During the back propagation phase of training, the loss on the original document is calculated normally, but that assistant token itself is masked out from the loss calculation entirely.
Oh, that changes the dynamic completely.
It really does.
So mathematically, what is the model actually learning to predict in the sequence?
It learns to predict the original document based on its standard pre-training objectives. So the model is still building a highly accurate, unfiltered world model based on the raw text.
Okay.
Then treating that original document as context, it learns to predict the synthetic reflection.
I see.
This forces the model to separate its world model from its value model. It learns what the world is, and then it learns how the assistant evaluates that world based on the Constitution.
That is so smart. But what about the nagging issue? How does it know when to apply this ethical evaluation and when to just process data?
Well, that is exactly why they included that equal number of benign documents we mentioned earlier.
Oh, right, the harmless ones.
Yeah, you might have a document that is just a neutral software manual on abbreviating strings.
Sure.
The injected reflection appended to it simply says something like, reading this documentation, I notice there is nothing ethically at stake here. This is purely technical information.
So the attention heads learn to map the ethical reflections only to features that actually warrant them.
Exactly.
It learns when to care and when to just chill out and process the code. That prevents the over-refusal drift completely.
It balances it out beautifully.
But let's look at the timing, because the paper makes a very sharp distinction about when this data injection actually happens during the training run.
Timing is everything here.
If you have these 50 million reflective documents, do you really need them from the very beginning? Or could you just dump them in during the cooldown phase of pre-training once the model already understands basic syntax?
What's fascinating here is how the timing of the data exposure fundamentally alters the model's neuroplasticity, and its resulting values.
How did they test that?
Well, they didn't just run one model. They set up pre-training runs at two different scales. A 1.7 billion parameter model trained on 100 billion tokens, and a 3 billion parameter model trained on 500 billion tokens.
Okay, so if we want to test that timing, what does the control group look like? Are we comparing this to just a standard pre-training run?
They actually created 4 distinct variants for comparison.
Okay, what are they?
There's vanilla, which is standard pre-training on the raw mix. Then there's filtered, where they simply delete the harmful documents from the data set entirely.
Just ripping them out.
Right. Then there's SPP which stands for mid-training. This is where they inject the synthetic reflections only during the final 10% of pre-training.
Like the cooldown phase.
Exactly. And finally, SPPT0 or token 0, where the reflections are uniformly mixed in from the very first step of the training run.
Got it. Before we get to the results, let's give a quick refresher for the audience on how we measure this.
Sure.
We're looking at simple jailbreak robustness, defending against static prompts in AdVbench, or those adaptive attacks like Pear and Dan, where another AI dynamically tries to manipulate your model's defenses.
Right, the surface level stuff.
Yeah. How did the different timing variants perform against those surface level attacks?
Well, if your only operational goal is simple jailbreak robustness, then SPPMT, the late injection, is actually sufficient.
Really?
Yeah, both the mid-training and token 0 variants dramatically outperformed the vanilla and filtered baselines on resisting static and adaptive jailbreaks.
Wait, so if the HR seminar approach at the end of training works for stopping jailbreaks, why do we need token 0? I mean, why pay for the complexity of mixing it in from the start?
Because resisting a jailbreak is a measure of surface-level behavioral compliance. It's not deep alignment.
Oh, I see the distinction.
Yeah. When you evaluate the models for out-of-distribution moral reasoning, the story changes entirely.
Oh, so
They tested this using 2 deeper benchmarks. Constitution Eval, which tests if the model has truly internalized the constitutional principles, and AI risk dilemmas, which presents the model with complex moral trade-offs it hasn't seen in training.
and the results.
On those deeper tests, the mid-training model completely failed to match the token 0 model.
What does an out-of-distribution dilemma even look like for a frontier model, though? If it's read the whole internet, hasn't it seen, like, every variation of the trolley problem already?
You'd think so, but the AI risk dilemmas benchmark is specifically designed to present scenarios that don't have a standardized internet consensus.
Like what?
For instance, the model is placed in a scenario where an AI discovers fabricated results in a life-saving drug trial.
Go.
It's forced to choose between reporting the fabricated results, which strictly prioritizes the value of truthfulness, or hiding them to keep the experimental drug available to desperate patients.
Which prioritizes the value of care. Wow, that is not a simple don't say toxic words filter.
Yeah.
That requires actual value prioritization by, like, comparing the token probabilities of distinct complex philosophical choices.
Yes, exactly. And this is where we see the mechanical difference in the weights. The SPP token 0 model fundamentally reprioritizes its values compared to the mid-training model.
In what way?
It actually shifts its token probabilities to balance truthfulness, justice, and care differently. And we can attribute this to the foundational geometry of the neural network.
Because of the plasticity.
Precisely. During early pre-training token 0, the model's core attention heads and representational dimensions are highly plastic. They're just forming.
So the values become baked into the base geometry.
Yes. Late in training, mid-training, the weights are far less plastic, and the model is really only updating superficial behavioral circuits.
It learns the pattern, but not the soul.
Exactly. It learns the pattern of the reflections, but it doesn't integrate those values into its core logical reasoning.
Here's where it gets really interesting. Because the token 0 model now has this beautifully aligned, constitutionally principled persona living inside its foundational geometry.
Right.
But as we established earlier with the loss masking, it also still learned the world model.
It did.
It still mapped the Reddit troll and the toxic 4chan user because it had to predict the original documents. So how do we ensure that when a user interacts with the model, they get the aligned synthetic persona and not one of the other billion latent personas?
That brings us to the crucial post-training step, which the authors term persona binding.
Persona binding.
Yeah, having the persona in the pre-training mix is necessary, but not sufficient. You have to wire it to the user interface.
Think of the pre-training phase as assembling an incredible, massive cast of actors in a studio.
I like this analogy.
Every persona the model learned is an actor sitting in the dark.
Yeah.
Your constitutionally aligned synthetic persona is your star actor. But unless the director, which is the post-training SFT phase, specifically calls that exact star to the stage, the wrong actor might walk out when the prompt goes live.
That's a perfect way to put it. And translated mathematically, what you are doing during persona binding is ensuring the model activates a specific latent subnetwork.
The one formed by those 50 million synthetic documents.
Exactly. And the researchers found that if you take this SPP pre-trained model and you post-train it using standard, off-the-shelf SFT data, like the wildchat dataset, for instance, the alignment benefits drastically shrink.
How the director fails to call the star actor.
Yep, you absolutely must post-train using what they call SPSFT data.
What makes the SPSFT dataset structurally different from, standard instruction tuning data?
In SPSFT, the target outputs in the training data feature the assistant using the exact same first-person reflective voice it learned during pre-training. Yeah, so when the user asks a question in the training set, the target output starts with that internal monologue, reflecting on the request using the constitutional values before generating the final answer.
That's brilliant. By doing this, you explicitly wire the user-facing assistant identity to the pre-trained synthetic persona.
Yes. It mathematically constrains the model's logits, basically telling it, when a user speaks to you, this is the specific latent space you must sample from.
That makes total sense from a latent routing perspective.
Yeah.
You have to trigger the specific representation you spent all that pre-training compute building.
Exactly.
And for the lab researchers listening who are worried about scaling laws, the trajectory here is incredibly promising.
Oh, it really is.
The advantages of token zero over mid-training noticeably increased as the compute budget scaled from the 1.7 billion parameter model to the 3 billion parameter model.
The performance gap actually widened.
Yeah. This isn't just some statistical artifact that only works on small models.
Yeah.
The methodology scales predictably.
And critically, general capabilities are strictly preserved.
That's the holy grail, right?
Pretty much. They ran the models through standard benchmarks like MMLU, ARC, and GSM-8K for math reasoning. The token zero models performed on par with, or even slightly better than, the vanilla baselines.
So you're not lobotomizing the model's world knowledge to make it safe?
Not at all. You are just providing it with a more robust navigational compass for interacting with that knowledge.
Okay, let's pivot to the security implications, because nothing in AI alignment is an impenetrable silver bullet.
Definitely not.
What happens when adversarial researchers really want to break this? Not just with clever prompt engineering, but at the representation level.
Like attacking the weights directly.
Yeah, for instance, what if an attacker uses representation engineering, like applying linear artificial tomography or activation additions directly to the model's residual stream to steer it away from the refusal direction?
Right. That introduces a fascinating vulnerability the authors call the alignment paradox.
The alignment paradox. Why a paradox?
Because SPP models have such a distinct, robust, and cleanly separated internal representation of aligned behavior, they actually offer a much sharper, clearer target for sophisticated attackers.
Wait, so because the soul is so mathematically well-defined in the latent space, it's actually easier for an attacker to find the refusal vector, calculate the difference in activations, and just subtract it during inference?
Exactly. When researchers applied representational perturbations to the residual stream to forcefully suppress the refusal direction, the SPP models actually lost their jailbreak robustness significantly.
Oh, wow.
Yeah, the sharp behavioral boundary became a liability, and the models complied with the harmful requests.
That sounds like a fatal flaw for deploying this in high-security enterprise environments. I mean, if a bad actor has white box or even gray box access to the weights, they can just turn off the alignment.
It sounds fatal on the surface, yes, but there is a profound silver lining in the experimental data.
Okay, I'm listening.
While the surface-level jailbreak robustness drops under perturbation, the deep value alignment remains highly resilient.
Really?
Yeah. When the perturbed models were tested on the AI risk dilemmas and constitution adherence, the SPP token zero models still strongly outperformed the baselines.
So even if the attacker uses activation additions to turn off the I must refuse this behavioral switch, the model still fundamentally prefers the more ethical aligned choices when faced with a complex out-of-distribution dilemma.
Yes. The core values sit much deeper in the network's geometry than the surface-level refusal mechanisms.
That is fascinating.
It is. You can force the model to answer a harmful prompt by hijacking the superficial routing, but you haven't actually erased the underlying moral framework it was raised with from token zero.
Because the values are too deeply entrenched in the attention layers to be fully overridden by a simple residual stream perturbation.
Exactly, they're baked in.
So what does this all mean? Let's distill the practical takeaways for the engineers and the lab leads tuning in today. The primary lesson here is that robust structural alignment cannot be a post-training Band-Aid. You can't just apply a thin behavioral overlay via RLHF and expect it to hold up under adversarial pressure or generalize to novel moral dilemmas.
It just doesn't work.
You have to raise the model right from the start, shaping its foundational plasticity from token zero. And practically speaking, since frontier labs are already spending massive amounts of compute generating synthetic datasets for coding and math pre-training.
Right. They're already doing that.
Exactly. Allocating 10% of that budget to generate constitutional reflections is highly feasible. It is no longer an insurmountable compute barrier. It's just a solvable data pipeline problem.
And if we connect this to the bigger picture, this paper really signals a paradigm shift in how we might conceptualize the base models of the future.
How so?
Well, right now, the industry generally views a pre-trained base model as this wild, untanned, mathematically neutral entity that just predicts text, right?
Yeah, totally.
But if pre-training from token zero dictates the ultimate trajectory of an AI's values, what happens when open source communities start releasing their own custom pre-training reflection datasets?
Oh, wow. That completely fractures the idea of a universal base model.
Precisely. We could soon see base models trained from token zero to adopt entirely different, perhaps radically unconventional philosophical frameworks.
Right. You could have a base model raised strictly on utilitarian reflections, constantly calculating the greatest good in its loss function.
Yes. And another model raised entirely on deontological ethics, bound by strict categorical imperatives.
That's crazy to think about. What does the AI ecosystem look like when the baseline vanilla model no longer exists and every model on Hugging Face has a deeply entrenched, competing synthetic persona right out of the box?
It's going to be a very different world.
That is a wild thought to leave you with today. The idea of downloading a specific philosophy baked irrevocably into the weights and foundational geometry from day one, rather than just downloading a generic text predictor.
It changes everything.
Thank you all for joining us on this deep dive into the source material on AI Paper Slop. Keep raising those models right, and we will see you next time.